Hello and welcome to this quick guide on getting started with iNav 8.0. This guide is going to go over basically how to get started with iNav 8, install it onto a flight controller, install iNav configurator itself, and really the main settings that I use to get off the ground. This will look at more of a fixed wing settings that I go through, not so much quadcopters. I mostly fly fixed wings these days. So anyway, you'll get started by going to the iNav configurator page in GitHub. I will have a link to this below in the description, but here it is. This is actually for the 8.0.1 release candidate 1. I usually stick on full versions, but it's up to you at that point. Release candidates typically have things that people are testing and are not verified to be stable. So go with the full iNav versions if you're just getting started, really. But here you would scroll down until you see the Assets tab and download for whatever version you need for whatever computer you're using. For me, I use Windows, so I would download either the Windows 64 MSI or the Windows 64 zip. From there, just follow the installation instructions and you should be good to open up iNav. So here we have iNav. We'll make that full screen. And this is the iNav configurator. iNav is what you install onto a flight controller. Just to avoid a little bit of confusion there, it's probably a little confusing at first. This is not iNav, this is the configurator. This allows you to install iNav onto a flight controller. So one thing you may want to do if you are on Windows, go through and install the STM USB VCP drivers. You will have to log into STM's website, kind of a pain, but once you're done, you don't have to deal with it anymore. And then the Zadig for Windows DFU flashing, make sure you grab that one as well, because we will need that one here in a few seconds. So let's get started. With your flight controller, the one that I'm using as an example is an F405 from SpeedyBee. It is the F405 wing, and they come with a little USB breakout board that typically has a boot button on it. What we're going to do is make sure we have a USB cable connected to our computer, and we're going to hold that boot button down while plugging in the USB into the little USB extension from the flight controller. From there, we have lights going off on the flight controller, and we can see up at the top here, we see DFU. That means we are in the proper mode to flash iNav to this flight controller. So we can go to the firmware flasher tab here. And what I like to do to filter down the options a little bit is just type Speedy, and that'll give me the SpeedyBee options for the boards. Typically the target, which this is, you're looking for the target here, is given to you in some sort of documentation for the flight controller. So if you're lost on that, just refer to the manufacturer's documentation. They typically will tell you the name of the target for iNav there, as well as other softwares you can install onto these flight controllers. But for me, the SpeedyBee F405 wing. From there, we will select iNav 8.0, and other than what's default checked, I typically like to make sure it's a full chip erase. That will save me from having problems if I'm using a older version of iNav. I wouldn't want things carrying over and potentially messing things up. So sorry about that. We'll make that slightly smaller. We'll say load firmware from online and flash firmware. We're going to first go through the erasing step here. Take a few seconds, and then once it is fully erased, it will start flashing. It does take a second, but give it some time and it should flash no problem. Okay, so now we are done flashing. We see the programming successful here on the bottom, and the port here changed from DFU to an actual COM port. That means that we are good to connect to this flight controller. So let's hit connect. We're going to get started with sort of a default preset setup for this flight controller. Let's just pretend it's for a wing. So, for example, the AR Wing Pro. We'll pretend it's for that. So that would be an airplane without a tail, wing, delta, etc. If you had an airplane with a tail, like an actual vertical and horizontal stabilizer. You would say airplane with a tail. You also have quad options here, as well as rovers and boats. We're going to do airplane without a tail. And that's going to set some of the presets in the mixer for us, so we don't have to do quite as much work. A new thing with iNav 8 is now we have a little bit of a receiver and GPS wizard. So right off the bat, once we install iNav, we're going to get prompted to select the ports for the serial or for the receiver and the GPS. So UART1 is a good port for the receiver, and this is where you would pick your receiver protocol. There's various different protocols to choose from. Most FPV pilots are going to stick with the CRSF protocol, and that would include Crossfire and most ELRS stuff nowadays. But there are other options like Mavlink and some iFly and FrSky options as well. So we'll hit next on UART1 in CRSF, and now we have the GPS wizard. UART3 is good. The baud rate at 115/200 is fine. It is a GPS protocol. I think most FPV GPS units use the uBlocks protocol. So let's hit next, and it will save and reboot. It's a common theme that you'll find in iNav. You will be saving and rebooting quite often, and it's good to save and reboot as often as you can. So now we have a little bit of a setup page here where you can see the orientation of the craft. This will help you sort of verify that you have everything all lined up properly. If you tilt the flight controller forward, the nose should go down, back, left, and right. You can also make sure if it's mounted in the craft properly with the pitch and roll settings. I like to face the plane away from me just to make it easier on my brain, and hit reset Z axis, and there you can sort of really tell what you're doing in relation to the flight controller. As also a note, I like to do these steps first with the flight controller out of the plane or whatever you're installing the flight controller in. It just helps you when you have to do some soldering and fine-tuning to the flight controller. You do also get some pre-arming checks and other statistics about some of the telemetry on the craft here. But we'll move on to the calibration tab. This is where we will calibrate the accelerometer. It's pretty straightforward. We'll hit calibrate and move the flight controller into the position we see on each step. In between each, we'll hit calibrate, move the flight controller, calibrate, move the flight controller, and hit calibrate. Pretty simple. So we'll start with the flight controller just flat on a table. Nice to have a flat surface for this step. And we will hit calibrate. It'll basically give you a rundown of what you're doing, what I just explained. Hit OK. Calibrate again. It'll try to lock in that first position. There we go. We will flip the flight controller, still facing away from us, but face down, and hit calibrate. Perfect. Now we will have the flight controller facing towards us and then to the right. Calibrate. Now we'll have it pointing straight up and hit calibrate. To the left, hit calibrate. And straight down and hit calibrate. Okay. Sometimes if you're calibrating and you lose the first step, don't worry about it. Just continue with the steps and go back after and save that first step. So we're good now. We will hit save and reboot. And it will save and reboot. Perfect. So we will go to the mixer tab next. Like I said, at the very beginning, we sort of already did this, dealt with this tab with the preset we selected, and that would be for an AR Wing Pro, which has one motor and two control surfaces. So S1, the S1 port on the flight controller is going to be designated for the motor here. The S3 port on our flight controller is going to be for the left servo, servo 1 here. The right servo, or the right control surface here, is going to be on S4 on our flight controller, and that will be the second servo there. This is also where you can change the weights. If you're noticing that iNav doesn't really have enough throw, sometimes it happens, you can increase these all the way up to 100%. 100% is typically a little bit too high on most planes, but we should be good there. This is also where you can change the preset if you selected the wrong one at first. Say you needed just a regular old airplane, you could select that and you'll be good to go. But for us, we are going to stick with a flying wing, and we should be good. We will hit save and reboot and move on. Also, sorry, if you do select airplane, you'll have to hit load and apply, and then it will apply that mixer, and then you hit save and reboot. But for us, flying wing, load and apply, and we will hit save and reboot. It'll do it for us in iNav 8, I guess. So it will save and reboot, and we are good to move on to the Outputs tab. The Outputs tab is the output of the mixer. So you will see, if you do have your receiver connected up and bound, you'll see the channels moving as you move your sticks. And also on this tab, you can enable and test the motor there. I typically only do that with the props removed, as you should. Props can be pretty dangerous. But that's a good way to make sure that your propeller is spinning, or the motor is spinning the right way for the propeller before you get to the field and find out that it's spinning the wrong way. You can also reverse your servo direction here if you find that you're pulling back on a stick to pull the nose up and one servo is going down while the other is going up. You can reverse the servo there. One more thing that is very important to do on this tab, you see this big red message, PMW outputs is disabled, motors and servos will not work, use outputs tab to enable. That is right there. Without that, you will not get a motor output, you will not move the servos. So hit save, and we'll actually hit save and reboot, just to be sure. One more thing to note on this tab is the ESC protocol. Leave it at standard, there's no need to change it. We'll move on to the ports, and here we have the pre-selected ports for the serial, for the receiver that we specified earlier. UART1 is our serial RX, and then UART3 is for our GPS. For me, nowadays, I only fly digital systems, and I fly the DJI 04 and 03 systems. So here, you may want to check with your flight controller depending on what power requirements you have, but a lot of them will have a pre-pinned header for DJI systems. And so for me, that would be TX and RX5. So UART5 here. I would go to peripherals and select MSP display port. For most modern digital systems, that's what you're going to select. And we will hit save and reboot. A quick note on the SpeeDB flight controllers is typically they have a Bluetooth capabilities as well, so you can connect to your flight controller from the SpeeDB app. Typically that is on UART6, and that's why we have the MSP on UART6, and that's the Bluetooth transmitter and receiver that allows us to connect to the flight controller via Bluetooth. So let's move on to the configuration tab. Here, there's a few things that I change here, and that is the continuous trim servos on fixed wing. That'll just continuously trim the servos, so we should be flying nice and level depending on the conditions. And I permanently enable launch mode for fixed wing. So the moment you arm the craft after you have a GPS lock and everything, you will be in launch mode, and I'll talk about that a little bit in the later on. But those are the two settings I like to have enabled. So historically, or in older versions of iNav, you would need a dedicated switch for launch mode. Now you can just always have it on, so when you arm, you're good to launch, and then from there you're fine. One thing, if you do make changes to the ports, specifically the GPS port, you may have to go in and re-enable GPS for navigation and telemetry. I don't actually change any battery settings here. I just go off of what the voltage says. So we will hit save and reboot. And we will move on to this failsafe page. I leave this at land. That is because I'd rather have the plane just land than me have it circle over my head for an hour. I would probably recommend you just say land in all cases. If you're using iNav, chances are you have a GPS and you have navigation capabilities. So just say land. It's going to be what's best, I believe. Save and reboot. And we will move on to the tuning tab. Sometimes it takes a second to load, especially if you're impatient and click on the tuning tab before it actually loads. So let's actually hit disconnect and reconnect. See if we can speed it up a little bit. Waiting for data. Let's hit disconnect and we'll unplug it and just replug it in really quick. We'll hit connect. There we go. So let's get into the tuning tab here. This is where the tune that helps improve the plane's flight can be done. There's the PIDs basically. If you're from a quadcopter world, I actually don't touch these. I let auto-tune do that, and I will explain that a little later. So let's move on to the advanced tuning tab now. I do make some changes here, and that would relate to first the auto launch settings. I changed the idle throttle to 1450, and that'll put the throttle to about half. The moment you arm, that motor's going to spin, and it's going to spin at about half throttle. Depending on what you want, that may not be what you want. You may be nervous about the propeller spinning while the plane is in your hands, and you can leave that at 0 and have it throttle up after it's detected the launch and after it's out of your hand. But for me, I leave it at 1450, and I'm just a little bit extra cautious with the propeller. 75 on the max throw angle. I change that to 180, just depending on if I throw it real goofy, it's still going to try to auto launch. I do up the launch throttle to about 1750. If I notice the plane is struggling on the first launch, I'll up that, or typically it's only increasing it, not really going lower than 1750. The launch timeout I will increase from 5,000 milliseconds to 10,000 milliseconds, so that gives us a 10-second launch timeout. So this means that the launch will keep going for 10 seconds. 5 seconds is a little bit short if you're trying to fumble and get the goggles on, get yourself situated, and take over the craft. So I like 10 seconds there. The maximum altitude I also increase from 50 meters to 100 meters, and I think that's just a little bit nicer of a gap between the ground and the craft there. So now we will move on to the RTH settings, another place where I make changes. We will say, again, from 50 meters to 100 meters. 50 meters feels a little too close to the ground for me to have a plane coming back. Just not a lot of room between not a lot of mistakes high, basically. We'll also put that into the RTH home altitude, and that's the altitude that the plane will stay at once it is returned to home. The only other setting I change on the RTH settings is I make sure that we use a linear descent. So if you are flying out on a mountain and you hit return to home, it's going to linearly descend to that 100 meters. It's not going to dive straight down to the 100 meters and then return to home. Makes it quite a bit nicer to not as jarring on the plane to use if you use linear descent. Keep this land after RTH on failsafe only. That's typically what I do. I don't want it to land if I'm just needing to return to home and circle over me while I fiddle with my goggles or something like that. So I do also, in the fixed wing navigation settings, I allow manual throttle increase, and that's just, say for example, you're returning to home and struggling a little bit, you can move the throttle stick up, and that will give you a little bit more power to get back if you need it. The only other thing I change in here is I say instead of a 7,500 centimeter loiter radius, I give it a 10,000 centimeter loiter radius, or 100 meters there. Just gives it a little bit of wider circle so it's not banking so hard, especially larger, faster planes. It's a little bit of a tight circle for them to make. So that is all the settings I make there, or only changes I make there. So let's go ahead and say save and reboot. There it goes. Perfect. We'll skip over the programming tab. I may make a video on that later, but for just getting started, you don't need to deal with the programming tab at all. But for the receiver tab, this is where we may need to make a change. For me, the channel map is throttle, T-A-E-R. So we will say T-A-E-R, perfect, throttle, aileron, elevator, rudder. And that is the only change we need to make here, because again, we did make some presets from when we initially installed that we have a serial receiver and it is using the CRSF protocol. This tab is also nice if you're having a little bit trouble forwarding your channels. This is a good debug channel or debug page to see what's going on with your channels, how are they being forwarded, and what you may be doing wrong. A little bit of word advice on wiring. This isn't a wiring video, but try, if your flight controller has it, to use the 4v5 pad instead of a 5-volt pad for your receiver and GPS. That will allow you to have them powered on when they are plugged in via USB, and you can do some testing without plugging in a battery, which is really nice to not have to plug in a battery just to test your receiver and GPS. So we will hit save and reboot here and move on into the modes tab. The modes tab is sort of personal preference on how you want it set up, but for me, I have a pretty consistent setup. That way I'm not trying to guess what did I set up for the return to home or arm on this specific plane. It's generally across the board for me the same for my planes and for my quadcopters. So let's, hopefully it loads here. We'll hit disconnect, we'll unplug, we'll replug here and hit connect, and we'll go into the modes tab. For me, on ARM, I'll hit channel 5, and that is my right shoulder button, my Tango 2, and that will work just fine. What you can also do is hit auto and press the button or switch that you're wanting to use for that mode. But for me, I remember which channels or what switches are on what channel, and this setup tab with this modes setup has not changed for me in a long time. So angle, we want that on channel 6, a 3-position switch there on the N. Manual, again, channel 6, that'll be the first setting. So on the 3-position switch, the first setting is manual. The middle is actually acro. Acro is the absence of any of these other flight modes. And then the last position will be angle mode. We'll move on to set the nav RTH. That is going to be channel 8. That is my right shoulder button there. It's a 2-position shoulder button. We'll move on to auto tune. I have that on channel 7. This is a 3-position switch, but I sort of treat it as a 2-position switch here. I may make a video on auto tune here with a nano drag build that I have needing to auto tune, there are some other also good guides on auto tune for iNav that you can take a look at. But for right now, that is on channel 7. And then auto level trim, I will set that to the same settings that the angle mode is on, channel 6, and all the way to the right there. And that's just going to help our plane auto level trim. Do what it says. Auto level trim on channel 6 on the last position there. So we will hit save. There's a lot of other things that you can do in here, like enabling your waypoint, lots of different things like that. But these are the general settings that I use. We'll move on to the GPS tab. And this is where you can sort of change some settings for the GPS, as well as verify if you are outside. Typically, if you're inside, you won't get a GPS signal. But here you can verify that your GPS is in fact working. I like to see that it's sending messages here. You'll see this total messages count climb pretty quickly if your GPS is in fact sending messages back. I do actually set the North American WAAS as the ground assistance type. Depending on where you are, you may set it differently, as well as the using extra satellites potentially there. But that's all we need on this tab, so we'll say save and reboot. And we will move on to the mission control tab. This is where you can sort of set waypoints if you want. I typically don't do that. Mostly fly FPV to manually fly the plane, but there are options for waypoints in here if that's what you want. You can set lots of different parameters for waypoints in this page. I may make a video specifically going over this tab in the future. The last thing that we get to do on the flight controller to set it up is the OSD. You have different video formats. I believe PAL is for analog, and then we have HD0, DJI WTF, which is a special firmware for early DJI video systems. And then there's Avatar, which is Cadix Walksnail Avatar system. Betaflight 4.3 compatibility, and then Betaflight HD compatibility. For the DJI 04 and 03 system, I will use the Betaflight HD compatibility video format. And that's just going to give us the proper OSD layout here. For me, I deselect RSSI and battery voltage. I go off of the battery cell voltage. It may not be quite as accurate, but it gets me enough information I know to determine where to land. System message goes down there. Acro, or the flight mode, goes right there. The fly time, or the on timer, goes there. Satellites down here. These are default altitude, throttle, amps, and total milliamps pull or milliamps drawn there. After that, it's only a couple things I add. You do have lots of options here on what you can add, and I believe in a new update, DJI has added even more OSD elements to iNav, which is super great and has been a long time coming. But here I will add the the direction to home. Sort of nice to have, especially if you're flying a little bit further away. Once you get further away, it's sort of difficult to determine where you actually are. And if you don't want to use return to home, this is really nice to fly back yourself. The only other thing I will add is the uplink quality to the receiver. There we go, the link quality, as well as the TX power in milliwatts. So I know how much power my transmitter is actually putting out. Am I on 10 milliwatts or am I on 1 watt? Because it makes a difference in how much range I mentally have left. So that is really it. There's a whole bunch of different settings in here, but this is really the simple ones that I do to get started with iNav. And I think if you follow these steps, you'll get off the ground pretty quick and pretty painlessly. So anyway, thanks for watching, and I hope to see you guys in a future video. Bye.